Hi, my name is Rachel Housley, and this is my third lab video for Chem 1412, Equilibrium and the Chatelier's Principle. So in this lab, I will be using copper 2 chloride, sodium chloride, silver nitrate, and water to perform an equilibrium reaction, pushing it forwards and backwards, and seeing how each of these chemicals play a role in that. Additionally, I will be looking to see the effect that temperature has on equilibrium. And then at the end, I will collect my data and decide whether or not this reaction is exothermic or endothermic. Okay, I'm beginning the equilibrium and the Chatelier's principle lab. I have weighed out approximately 4.5 grams of sodium chloride into the weighboat, and I'm going to pour this now into the 25 milliliter Erlenmeyer flask and mix it with water until the salt dissolves. Okay, so I have labeled the test tubes and added 2 milliliters of copper 2 chloride solution to each one. I'm also about to add 1 milliliter of the concentrated salt solution into test tube number 2 after I have recorded the color of the number 1 solution, which is blue, a light blue. So after adding the sodium chloride solution to the copper 2 chloride solution, I'm now observing the different colors for each test tube. So test tube number 1 is just blue to me. Test tube number 2 looked turquoise. Test tubes number 3 and 4 looked pretty similar to me. Test tube number 3 maybe is a little bit more of a sea green, whereas number 4 is more of a grassy green. And test tube number 5 was the same as test tube number 4. Okay, so moving on to activity 2, I am now adding 1 milliliter of the silver nitrate solution to test tube number 3, and then I'm going to put a timer for 5 minutes and record what I see. Moving on to activity 3, I am about to add 3 mils of water to test tube number 4 and start with the pipette. I'm going to compare the colors after this. Okay, so comparing test tube number 4 to number 5, 4 is definitely a little bit more blue. It's an aquamarine color, whereas the 5 is still the grassy green as before. Okay, the 5 minutes are up for activity 2, so I'm going back to compare test tube number 3 and test tube number 1. Test tube number 3 has a white precipitate on the bottom, and it's more of a milky green-blue color. And then, of course, test tube number 1 is still the clearish blue color. Alright, so I have my hot water bath at approximately 65 degrees Celsius, closer to 70, and now I'm going to add so after heating test tube number 5 in the hot water bath, you can see that there's a slightly greener tint than the test tube number 4 solution. Of test tube 5 indicates that the reaction has shifted to the right, and so yeah. Okay, after placing test tube number 5 in the cold water bath, and its temperature has dropped to approximately 3 degrees Celsius, you can tell it's slightly bluer than the solution 4, which indicates that the reaction has shifted to the left. So, in conclusion, when you compare the test tube number 4 to test tube number 5, in both hot and cold reactions, you can see that the reaction shifts to the right when test tube number 5 was heated, and it shifts to the left when it was cooled. So because of this, heat would be a reactant, making this reaction endothermic. It's absorbing heat.